Alright guys, so we're going to go over question 4, but before we do go over question 4, I want to add something to question number 1, really just clear something up, okay? So the whole thing is, what we're talking about is Newton's third law. Every action, equal and opposite reaction. A couple of bullet points we talked about was that it has to be the same type of force. The action-reaction, same type of force. And up here I want to eliminate any confusion, because we said that the force of the normal force equaled the force of gravity. Now, we automatically know that, but I don't want you guys to assume it's the same because it's the action-reaction deal. This equals normal force and force of gravity in this case are equal, but that's because not Newton's third law, okay? So let's talk about why. So we know that the overall force, you see this, equals the normal force minus the force of gravity, okay? And we know that equals mass times acceleration. So, and we know, so bear with me, I know this is a lot of equal signs, right? So let's take it one step at a time. Let me get something to break this up a little bit. Our overall force equals the force of the normal force minus the force of gravity. We know that the object is not moving up or down, right? So we're talking about our up and down, our y force, right? So we know that our force of gravity is, what did we say it was? 280.28. So 280.28. That's our force of gravity. So we know our overall force, our y force, up and down, equals our normal force minus our force of gravity, which we already figured out. But we also know that that equals mass times acceleration. So this is why it's the same, and it's not because of Newton's third law. It's not because every action equal and opposite reaction, because as we said earlier, it's equal and opposite reaction on different objects. Well, number one, we're talking about the same object, just the crate with itself. And number two, same forces. Well, this is normal force, this is the gravitational force. So that's why it's not, we don't assume it's the same. We assume it's the same because our overall force equals mass times acceleration, which equals normal force minus force of gravity. Well, we know that our acceleration in this case, is it going up or down? No, it's staying the same. It's sliding left or right, but we're talking about y. So there is zero, acceleration is 0. So our normal force minus our force of gravity should equal 0. So in that case, our force of gravity is this. Our normal force has to be the same. Because now 280.28 minus 280.28 equals mass times acceleration, which just so happens to be 0 because this is 0. Because it doesn't matter what the mass is, the acceleration is 0. So that's why this normal force, we just rate it the same in this case, because it's not accelerating up or down. So in this case, the normal force is just 0, right? Okay, so we cleared that up. So now let's move it on down. We're going to do number 4. And the only reason I'm skipping to number 4 is because 2 and 3 are more or less the same as number 1. Okay, 2 and 3, same as number 1. I didn't want to beat a dead horse. You guys hopefully can go back and watch number 1 video. You can get 2 and 3. Usually the only difference is they change, as with all physics, they change what problems, what you got and what you don't got. So let's look at this one. Number 4. We have, okay, let's read it. A 6.58 times 10 to the third Newton upward tension force is exerted on a 521 kilogram downward moving freight elevator. Determine the acceleration of the elevator. Okay, so now, and as I said, the reason that I skipped to this one is because now we're dealing with the y-axis, and we know it's moving, we're going to try to figure out which way and how fast. We know it's moving. So what do we got to find? We got to find the acceleration, right? So let's draw our diagram. I'm just going to make my dot the elevator. Okay, so there's an upward tension force of, I'm going to convert this because I don't want to mess with all this, so I know it's 6.58 times 10 to the 3. So I'm just going to move it 3 places. All right, 1, 2, 3, so add a 0. 6580. 6580 Newton upward force. And that's going to be the tension force, right? And we knew the upward force exerted, okay. And we know that its mass is 521 kilograms. Okay? So, let's do force of gravity. So we know the force of gravity equals, mass times gravity, which equals 521 times 9.8. 521 times 9.8, and 521 is our mass, right? Kilograms. Which is going to equal 5105.8. Okay, so our force of gravity in this case is, that's a negative sign, 5105.8. And I just put negative to indicate that it's downward. Okay, so let's talk about what we need, which is acceleration. Acceleration. So we know the overall force, this is our weird little like backwards looking E symbol for overall force, the net force equals mass times acceleration. So our overall force is the force of gravity minus, so our downward force minus, take a guess what the other one is, our upward force, our tension force. And you know that's going to equal, because that's our acceleration force, overall force equals mass times acceleration. So this is just split up, right? Let's do this arrow. This just split up to the force of tension minus force of gravity minus force of tension equals mass times acceleration. Okay? So let's do it all up. So now we have force of gravity. Let's see. Alright guys, so when we try to find our net force, they kind of throw this together. They give me, I'm looking at a general formula, but think about it like this. So let's think about our net force like this, okay? Our one direction force, in other words, our tension force, and we're going to add that to our other force, our opposite force is the force of gravity. Okay? So, in this case, we're using negative for the force of gravity because it represents downward. So that being said, we're going to do 6580, and we are going to add a negative plus, put it in parentheses, 5105.8. So if you're adding a negative, just know that you're subtracting it. So for confusion's sake, I'm going to rewrite it. 6580 minus 5105.8 equals our mass times our acceleration. If we know our mass is, can we still see in the screen? Awesome. Our mass is 521, and our acceleration we're trying to find. So our final number we're sitting on is 1474.2 equals 521 times acceleration. Since this is multiplying, we need to make it cancel, so we're going to divide by 521. Divide by 521. And I'm going to come over here. So our acceleration should equal about 2.83 meters per second squared. We're going to round to 2.83. And we know because it's positive, that's an A. Because this is positive, and we know our negative, like our gravity is down, or positive. So we know this direction is upward. Awesome. So hopefully that makes sense to everybody. If you guys got any questions, let me know. Great job.